Okay, is my mic working? Yes, it is. Awesome.
Perfect.
Okay. How many of you are still migrating to Angular from AngularJS? Okay, good. You're in the right place. Good. So Mike and I have become friends over the last year through various conferences. And last year in London for Angular Connect, we had a mission to go to as many historic pubs in London as possible. The only rule was that it had to be older than America, which is like, that's pretty easy.
We did 9 in 4 days.
9 in 4 days. Yeah, it was pretty awesome. So we were, thank you. So we were on the London Underground, and we found ourselves at this pub called Ye Old Cheshire Cheese in London. And it was underground, 3 floors. So we're drinking ale, and we're having a good time, and we're talking about, of course, like our favorite subjects, ngUpgrade and NgRx, because like what else would you talk about in a pub in London? But so yeah, exactly. So we're talking about this stuff, and we're like thinking about what do you do if you've got an application that's really complex and event-driven, and you need to migrate it from AngularJS to Angular. And so we were thinking about this and talking about this in London, and we decided to put our heads together and come up with some solutions. So we decided to build this little sample app. We're huge Star Trek nerds. And also, let's think about this. Klingons are basically the Vikings of the sky. So we built this dashboard system for a Klingon warbird ship from Star Trek. And it's using AngularJS, and you can see that there's a weapons component, a shields component, and a warp system component. And they all feed into this status component right here. And the ship shakes at 9.95. So this application was architected in AngularJS, and it has a few pieces of state. You can set the warp speed from anywhere between 3 and 9.95. The weapon systems can either be firing or online, and the shields can either be raised or lowered. There's also one side effect in this application. When the user presses fire torpedoes, you have to reach out to a weapons API and receive an asynchronous promise. So this is what the architecture looks like. We've got our components, and we've got a weapon service and a dashboard service. Fairly straightforward. But if you look over in the corner over there, you see this $root scope. And $root scope, if any of you have worked with it, it can cause some frustrations.
Red alert, Captain. We have some architectural limitations here. So we try to build this AngularJS app using AngularJS best practices to be fair to the framework. And there's 2 limitations that are going to make this difficult to upgrade to Angular. The first is that $root scope is everywhere.
Ugh.
So if we take a look at one of our services, whenever the user actually presses the fire torpedoes button, we're going to call the fire torpedoes method, which is broadcasting an event on $root scope. If other components, like the status component, want to be notified of when the user's actually pressed the button, they can register a callback using $scope to listen for that event. Now, this is good for an AngularJS application, but the problem is that we don't have an equivalent in Angular. There's no $root scope. And so if we're going to try and move this event-driven application to Angular, we're going to need some kind of equivalent. The second problem is that business logic is very tightly coupled to our view. So we take a look at the controller for the weapons component. It is calling our services directly. This is not a problem for AngularJS applications, and it's not a problem for Angular applications. But it is problematic when it comes to upgrading, because now we've got a bit of a chicken and the egg problem. Do we upgrade this controller first and the components to Angular, or do we upgrade the services first? And it's not really clear which direction we could take. Plus, as we upgrade this application, we're not going to be so lucky to be able to spend a week or month or year or however long it takes to do it on our own. Instead, we're definitely going to get new requirements, and we have to build new features and deliver new values to our customer as we're going through this upgrade strategy. So if our application, the warp drive algorithm could change, causing us to change the way we handle the state. The weapons system could change underneath us, causing us to have to reach out to new APIs that don't exist yet. And we may need to scale this application up for multiple different kinds of ships, giving us scalability issues. So the question is, for an application like this that has these architectural limitations and that needs to grow and scale while we're upgrading it to Angular, how can we successfully upgrade this app to Angular? So before we get into that, my name is Mike Ryan. You can find me on GitHub, Twitter, and Medium at Mike Ryan Dev. I'm a software engineer at Synapse, a Google developer expert in Angular and web technologies, and I'm one of the co-founders of NgRx and remain an NgRx core team member to this day.
To this day. I'm Sam Julien. I'm a content engineer at Auth0. I'm a GDE and Angular collaborator, and I created the course Upgrading AngularJS.com. And you can follow me everywhere at Sam Julien.
To this day.
So you might, yes, to this day, you can follow me at Sam Julien. So obviously, since Mike Ryan's standing up here, you probably have guessed by now that the solution for migrating this that we're proposing is NgRx. NgRx is a mediator between AngularJS and Angular. And what's great about this is that we can put all of our business logic in the store so that we can listen for changes and emit data down to the view layer and not be tightly coupled. What this means is we can actually use pretty much anything in the view layer. We can use AngularJS, we can use Angular. It really doesn't matter. But wait a second. Do we always need NgRx all the time, 100%?
Yes,
all the time?
Absolutely every Angular developer should be using
Okay,
NgRx.
good. Yeah, that's what I thought. I just wanted to be sure that we did. Okay.
You might not need NgRx. I'm going to say it on the stage again. And we're only going to recommend this as an upgrade strategy if your AngularJS application would actually benefit from the NgRx architecture in the first place. So you may need NgRx if the following is true and you're upgrading from AngularJS. You may need NgRx if you have application state that is changing frequently over the runtime of the application. So that would usually mean like you've got a piece of state or piece of data and you're getting a lot of WebSocket notifications causing that data to update very regularly to the point where you want to get some of the performance benefits out of NgRx. You may also need NgRx if you have many sources of change in your application. So what I mean by this is like your application doesn't just talk to a REST API, it's also maybe communicating over WebSockets, is using local browser APIs, and it has a lot of interaction from the user. And you may also need NgRx if you're building large-scale enterprise applications. So what I mean by this is NgRx does a really good job of decoupling concerns. If you're a solo developer building an Angular app, you're going to feel like you have to do a lot more work to get any value out of NgRx. But if you're working on a team, you can parallelize those tasks across your team and actually get a bit of a productivity benefit from using NgRx.
So what you're saying is, if I just have a run-of-the-mill CRUD application, I probably shouldn't use NgRx for this.
That's right. NgRx is not made for applications that are just talking with a REST API. So if you're working on upgrading an AngularJS application that communicates with just one REST API, this migration strategy probably does not make sense for you. I also want to point out that NgRx is not all or nothing. You can introduce NgRx feature by feature, module by module, and mix it up with other architectural patterns and still leverage some of the benefits of the NgRx architecture.
So we proposed the solution, but what's the fundamental underlying concept that makes using NgRx for this strategy so powerful?
Indirection.
Thanks for stealing my thunder.
It's indirection.
It is indirection. And that might seem like a really scary computer science-y word. So let's back up a little bit and actually explain what indirection means. It's one of those words that doesn't actually mean what you think it means. So normally in an application, you've got components and services that are talking to each other directly. And this is called directional communication. With indirection, what we do is we add a middle layer. We're going to call it the dispatcher in this situation. And the middle layer helps make the two sides not have to know much about each other. So this means that, let's say, for example, we've got our AngularJS component, and it needs to communicate with a torpedo service. Well, we can actually upgrade the AngularJS component to Angular, and the right side, the torpedo service, really doesn't care. It doesn't need to know anything about that. At the same time, we could swap out the torpedo service for a phaser service, and the Angular component wouldn't really need to know anything about that. So nothing on the left side would have to change.
I've got the perfect analogy for this.
Oh, okay.
So to me, indirection
interrupting me.
is a lot like when you go to a restaurant. You want to sit down and enjoy a nice meal. What you don't do is you don't like burst into the kitchen and say, hey, chef, please make me something, bring it to this table.
You don't?
No.
Oh.
Instead, what you do is you sit down, you politely wait for your waiter to come by and take your order. Then your waiter takes your order back into the kitchen. You as the patron have no idea how the waiter is communicating with the chef. You don't know how the chef's actually preparing the food. All that you care about is that you've put in your order, and then eventually the waiter's going to bring the food back to your table.
Yeah. Here's a cool diagram of emojis for that. So there's another example of indirection that you're probably already using on a daily basis, which is just component communication. This happens to be an Angular component. It could also apply to AngularJS, though. So think about a component that has inputs and outputs. We've got a shields component that's got an input of status and an output of raising the shields. If you think about it, this component has no idea who is binding to its input. And at the same time, it has no idea what is listening to its output. So this is actually indirection, and it's a type of indirection that you're using probably every day as you work in Angular. So now what we're going to do is Mike's going to do a little deep dive in how NgRx uses indirection, and then I'm going to talk about the practical steps of using NgRx to migrate with ngUpgrade.
So how does NgRx leverage indirection? Well, bit of a spoiler alert. Indirection's actually the source of all that boilerplate that you don't really care.
Boilerplate!
You're not Brandon. NgRx is the source of all that boilerplate that you need to write to build NgRx. Though really it's more like explicit code rather than boilerplate. And the reason for this is that NgRx deeply adheres to the single responsibility principle. So for the responsibility of transitioning state, we're going to write these kinds of functions called reducers for managing state transitions. Instead of components calling services directly, we're going to delegate the responsibility of communicating to the outside world using effects. And for handling interaction, well, that's the only responsibility we're going to assign to components. It's going to map events into some kind of change, and it's going to need to read data in from some kind of state container. And to pull this off, to do the single responsibility principle well, and to do it indirectly, we need to have some kind of communication layer that brings all these things together. And in NgRx, we call those actions. They're going to serve as a communication bus between these pieces of code. Additionally, components are going to need to be able to read some kind of state from our store, and we call those selectors. So let's talk about actions first. Now, actions, they're really like the gluten of the NgRx loaf, which is to say that they kind of bind an entire NgRx application together. To do this, what we want to do is we want to model the events that are arising in our application using this action interface. You're going to write objects that implement this interface, and at a minimum, you need to specify a type property. So that type property needs to be a unique description of the event that you're trying to capture, that you can add additional properties to the object to give that event context. For example, if we want to model the select warp speed button press of the user, we could create a select warp speed action, whose type clearly describes the event that we're capturing, and we can also add the speed to that action to give this event additional context. And what's going to be interesting is that as you go through this process, you're going to write actions for all of the primary events that are arising in your AngularJS application, including all the user events. But you're also going to capture the way your network requests are responding when you make HTTP requests. So when your HTTP client returns successfully for making a particular call, you're going to model that with an action to capture that event. And to pull out this indirection, we're going to need to have some way for components to communicate this to some kind of dispatcher. And in an NgRx application, that dispatcher is called the store. Components are going to inject the store service, and they're going to use store.dispatch to dispatch actions to the global stream of actions. From there, actions are going to reach to the primary consumers in an NgRx app, effects and reducers. Reducers have the primary responsibility of making state transitions. Every time a component dispatches an action, it's going to get that action along with some piece of initial state, and it's going to produce what we call the next state. Now, this next state object does something kind of interesting. The next time you dispatch an object as an action, it's actually going to take that previous state that your reducer returned, and it's going to get looped back into that reducer so that it can continue to iterate or reduce on the list of actions that are being dispatched in your application, creating a reactive cycle for maintaining state. Effects are the second primary consumer of actions. As your components dispatch actions, effects can receive them by filtering down on the actions observable. When they hear an action that they're interested about, they can perform some kind of side effect, and then they can model a response as more actions. And again, like reducers, the results of effects get looped back in. New effects and new reducers can listen for the actions coming out of your effects, allowing you to create a reactive cycle for managing side effects in your NgRx application. So actions introduce indirect communication between effects, state, and the view. When the view notices something interesting has happened, it's going to dispatch an action to cause state transitions and side effects to occur without knowing anything about how those mechanics work. But it also needs to be able to read in state from the store, and that's where selectors come into play. Selectors are functions for querying and transforming state in the store, and I really like to think of them as kind of windows into shared values. So we could write a selector like select shield status and apply it to the store to figure out if the shields are up or down in our AngularJS application. Our shields component can then inject the store and apply the selector using store.select to read in that state as an observable. And components use selectors to indirectly read state in the store using this mechanism. As a component, I don't care how that state got there or how that state was constructed. By simply pulling in the selector, I am free of having to know about those implementation details. So with my actions and selectors in place, my component layer has an indirect way to emit changes and to read state out of the store. So applying it to our AngularJS app, instead of $root_scope.on to emit events or to listen for state changes, we can use store.select to read in state changes from the store directly. And like inputs from Sam's example, this is an indirect way to read data from some parent where we don't have to know how the parent is working. And instead of $broadcast for emitting changes to some other consumer, we can use store.dispatch to notify about changes that are occurring in our app. And again, like outputs, this is an indirect way to let some unknown parents know that something interesting has happened in the application. And what's great about this pattern is we can apply it to our AngularJS applications just as successfully as we do with our Angular apps and introduce some kind of indirection between our AngularJS view layer and our service layer, allowing us to more easily in the future replace that AngularJS view layer with an Angular component layer.
So now that we've talked about how indirection works and how it works in NgRx, let's actually look at the practical steps of migrating with NgRx and ngUpgrade. So usually when you do a migration with AngularJS to Angular, you're going to pick one of roughly two types of strategies to do that. The first of these is called a component-based strategy. In a component-based strategy, this is also known as a horizontal strategy or horizontal slicing. You have your architected AngularJS app, and you start at the bottom of the dependency tree and work your way up, going from components with the least number of dependencies to the most number of dependencies. The other way that you can migrate is with a route-based strategy. This is also known as vertical slicing. And in this approach, you take an entire route and migrate it from AngularJS to Angular, and that way each route is controlled by one framework. With the NgRx upgrade strategy, what we want to do is insert a step before picking one of those strategies. And this is actually an architecture step. So with NgRx, we're going to force you to think about architecture before you migrate. And this is really important because everywhere I go at these conferences, people always come up to me and they tell me that one of the problems they always run into, aside from $root scope, is that the application that they started with many years ago with AngularJS has doubled or tripled in size, and now the architecture just doesn't match. So NgRx makes this really straightforward because you're actually forced to think about re-architecting your application before you migrate. So let's think about the steps that's actually going to happen in order to do this. The first thing, like with any NgRx application, you need to think through the actions of the application first. Now, luckily, we're working on an event-driven application, so the events correspond really nicely to the actions. So for example, we have a raising shields action and a lowering shields action that correspond exactly to our events of raising and lowering the shields. Next, after you define your actions, it makes it much easier to define the state of your application.
Actions really are like the dilithium crystals of the NgRx starship, aren't they?
They really are. You can tell we're pretty big Star Trek nerds.
They only get worse from here.
Yeah. Our application state is pretty simple, and it sort of corresponds to the components. So we've got a state, we've got shields raised, we've got the warp speed, and we've got firing torpedoes. So again, this makes you rethink the architecture first before you pick a view layer strategy of whether you're doing horizontal or vertical slicing. So after we've got that stuff figured out, it's time to move our business logic into things like reducers and effects. So for example, with a reducer, we've got the raise shields action and the lower shields action. So we have case statements for both raising the shields and for lowering the shields. For effects, we can use effects for things like having to reach out to an external API. So we have a fire torpedoes effect, and it's listening for the fire torpedoes action, and then it's calling out to the weapon service. After our business logic is migrated, we're now ready to downgrade the store using ngUpgrade and use it in our AngularJS application. So in our AngularJS module, we can use the downgrade injectable method from the ngUpgrade library and create a factory named store and then use it in our AngularJS components. So this is the weapons component again. This is the controller function of the weapons component in AngularJS. And we're actually injecting the store and dispatching an action from AngularJS, which is kind of crazy when you think about it. We can even use AngularJS services in NgRx code. So we've got our weapons service, and that's an AngularJS service that returns a promise. Now, note, so in AngularJS, we were using promises, not observables. But that's OK, because most of the RxJS operators that NgRx uses can actually work just as well with promises as with observables. So in our torpedoes effect, we have an asynchronous concat map that is basically going to await the promise from the weapon service. So we have ngUpgrade that allows us to fetch the injector from AngularJS, call the weapon service, and make that fire torpedoes call. And then we're able to dispatch the correct action once that completes. Finally, we can subscribe to state and replace all those instances of $on with selectors. So here we've got our status component. And in the status component, we can get rid of the $on from $root scope and use a selector to listen for the firing torpedo status and set the status accordingly. One thing to note with this is be sure to use the $onDestroy lifecycle hook of AngularJS to unsubscribe from your selectors. That way you don't cause any memory leaks or anything crazy like that.
So once you've gone through the process of re-architecting your AngularJS application, you're going to find that the migration can actually happen at a much quicker rate because you've gone through this pre-work of actually picking an architecture that's going to work across frameworks. So by removing the use of root scope, and instead of injecting our services, we're now injecting the store directly into our AngularJS components. And the result is that our AngularJS components no longer have any business logic in them. Instead, they're going to be selecting state from the store and dispatching actions. And what's great is that as you take this AngularJS component and migrate it to Angular, it looks exactly the same. It's injecting the store service, it's dispatching actions, and it's reading state from it using selectors, giving you a really easy migration strategy to go between one framework to the next. And the way we did this is we introduced indirection between the AngularJS components that we already have in our application and our service layer and our state transitions. $root scope is gone. We're no longer relying on AngularJS APIs that don't exist in an Angular world, simplifying our migration strategy. And all of our business logic is in the store. This means that we can have a mixed component layer. As you start to iteratively move those AngularJS components to Angular, they can both read from the same source of truth and dispatch actions to it. So, what does it look like to actually re-architect the application in NgRx? Well, I mentioned before, but actions really are the prune juice of the NgRx Klingon warrior, so you're going to want to write those actions up front. They're going to be a critical part of the NgRx migration. From there, you're going to want to write reducers to manage your state transitions and move that state off of $scope or out of your services or out of your AngularJS components and into the store. Instead of your AngularJS components communicating directly to your service layer, you're going to use effects to communicate to those services. And you can use AngularJS services in effects successfully by using the upgrade adapter. You can then downgrade the store to use it in your AngularJS components by using the downgrade injectable function that's coming from AngularUpgrade. And finally, you can subscribe to state that exists in the store by applying selectors directly to the state container. Once that re-architecture is done, you then pick a view layer upgrade strategy that makes sense for what remains in your application. So from here, you're going to pick either a component or a route-based strategy based on what makes sense for your application. If you want to learn more about this upgrade strategy, I recommend you visit NgRx.io. We have a fantastic team of collaborators that have already written advanced recipes that explain how to downgrade the store and use it in your AngularJS components.
And to learn more about ngUpgrade and how to walk step by step from AngularJS to Angular using the ngUpgrade library, you can check out my course at upgradingangularjs.com. We also have the slides and the whole sample application. We only showed the one screenshot, but we actually have a full sample application that has a branch showing all of this migration with NgRx. It's up on GitHub. So you can go to samj.im/ngvikings to get the slides, the repo, and a discount to the course. Did you have something to add?
It's a really cool sample application because we did not upgrade the component layer at all to Angular. It
True.
is a full AngularJS app, but it's just using the NgRx store for the business logic and communication. So definitely check it out.
It's pretty cool. Thank you.